Nice.
You could
Oh,
get to
why
I
did I
hope this
suddenly?
is all being recorded.
Yeah,
milliliters.
it has been. I don't know what happened there. I must have lose connection or something. All right, hold on. Let me try to get this to work. There we go. So guys, down here, see this? Do you see that? Yes.
Yes.
All right. I don't have pints, do I? Those
No,
jackasses. But I do have quarts, don't I? Can I go from pints to quarts?
Yeah.
Yeah. So let me just focus on this piece of the problem, okay? I'm just going to focus on this piece of the problem. And this is an example of where you just need to breathe. You realize these problems will sometimes have multiple steps, and you just accept that. Now watch. So what's the path that we've, so let me go back. The actual amount of pints, where'd it go? Let me see. 1 pint. All right, so we had 1 pint of milk that we're working with, right? In this problem. So.
Okay, we back on 205.
That's right. The problem's on 205. So what's the path I'm going to take? How can I get from pints to liters? What's the middleman going to be?
Well, you're gonna want to get 4 pints.
Don't bring numbers in. Don't bring any numbers in. What's the steps I'm going to take?
Quarts.
Yeah, if I can go from pints to quarts, I can then go from quarts
to liters. That's before we even get to milliliters.
So
yeah,
milliliter
exactly.
is more than a liter, right?
So
I'm confused on that part.
all right. So how's a meter and a millimeter compare? Which one's bigger?
I don't know, Jeff. That's what I'm asking.
Centimeter. How about a centimeter?
Centimeter is smaller, right? Oh,
Yes, and a millimeter is, millimeter is 1/10 of that. So a millimeter is much smaller than a meter.
Okay.
So you got to remember this. Remember King Henry died Monday. Get out of there. Drinking chocolate milk. So there's the meter. And this is 1/10, 1/10, 1/10. So a millimeter is 1,000th of a meter.
Right.
Yeah. So it's very small. It takes 1,000 of these to make one of these.
Did you make that up, or is that how you learned? Like.
Yes, both. I don't know. This is I kind of
like
heard
it makes a difference, but I'm saying that's pretty cool for your teaching, like as a student.
No. This is in the book. The King Henry thing. I'm pretty sure they put it in the book.
All right.
It's a known thing. I didn't make it up.
All right. Well.
Yeah.
Pretty cool.
Okay.
All right.
This is the step that I tried to tell you guys was really important, and that's the step that everybody's going to try to skip because you want to get done. And getting done is nowhere near as important as being right. So you're going to have to do this step sometimes. If you see, I don't see a conversion from pints to liters. Oh shit, I'm going to have to do a couple of steps. Okay. So I'm going to do this one with you. So we have 1 pint, right? 1 pint. And I want to go from pints to quarts first. So where would I put pints?
On the bottom?
Yes.
There's one.
No, not guitar jet. What is that? Crap. I don't know what gorts. Good old gorts. I need me a gort of milk. Yummy. All right.
Yeah.
What number goes where here?
2 pints.
2 pints is 1 quart. I like it. So now we're in quarts, aren't we? Pints go away. So where do I want to put quarts so they can't die?
Bottom. Yeah.
Bottom, so they'll cancel out. And now I can go from quarts to liters, and that's where I bring in this dude. 1.06 quarts is 1 liter.
Mm-hmm.
So here's where you got to be a little careful. All right. Here's where you got to be a little, here's where you got to be careful. So in your calculator, how are you going to put this in your calculator? What's it say? It says 1 divided by 2. And what's this doing? It's on the bottom, so what's it doing?
It's dividing.
There you go. That's what you put in your calculator. 1 is being divided by 2, and it's being divided by 1.06.
Okay. And what's next?
I mean, that's all I care
You
about.
waiting on the answer?
Yes,
No, I'm not waiting on the
Okay.
answer.
I didn't know why you stopped.
I am, Sal. That's all that matters right now. I think it's 0.4 something.
Or you're waiting on our answer. Okay.
Yeah, just do that.
All right.
Can I just put the 2 times 1.06 in parentheses?
You can, exactly. Just not a lot of people remember the parentheses. That's why I like to show this. If it's on the bottom, you divide. If it's on the top, you multiply. That makes it very simple.
0.24. Just put it like that.
No.
0.0. What is it? 1 divided by 2.
1 divided by 2 divided by 1.06. That's exactly how you put it in the calculator.
Oh, 47.
Yeah, 0.47 something or other. Yeah, that'll be liters. So do you remember we had a half a liter of milk? I'm sorry, half a liter or something, 0.47 liters of milk, and then it was something amount of juice. So to be
Okay.
honest, the way I would do this problem is I would make everything liters, because that's already liters. And the last thing I would do after I add them all together is convert it to milliliters, because they want milliliters. But I can't add the milk and the juice and the whatever unless they, water, I think, unless they have the same units. So I'm going to go ahead and make them all liters, because everything goes to liters.
Are we talking about number 4? Because it says they want to know how many ounces of juice.
No. No.
Okay.
Yeah. They give me ounces, don't they? They give me
Right.
ounces. It's like they gave me pints of milk,
Pints,
but we just
yeah,
convert
they
it
know
to
that.
liters. They give me ounces of juice. Now I got to convert that to liters. If I get
Yeah,
all
I
these in
agree.
liters, can I?
Right.
If I get these all in liters, can I add them together?
Hey, Jeff, when you have,
No, stop. Answer my question real quick, and then you can ask yours. If I get these all in liters, can I add them together?
well, they're in liters. Yes.
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 Of course. Thank you. Very good. Very good. Yes, Sal, you're right. It is a silly question, because of course I can. They're all the same units. And then when I get
Unless they're not the same units, you're just gonna write that whole together. Like, let's say, maybe I should shut up. Maybe I'll just be quiet.
That's why we're trying to get them to be the same unit, so I can put them all together. So when I get so many liters, I can then convert that to so many milliliters. That would be my last step.
Yikes.
That's how I would do that problem.
I'm learning, Jeff. I just don't mean to budge in like that. My apologies. I don't mean to be rude. And if I sound rude, I'm just sounded like we had a discussion right now. Or maybe that's just me feeling that way.
All right, that's up. Is when I ask a question, I want that answered before we go any further, right?
All right.
So we just did 1 pint of milk, and we converted it to 0.47 liters,
Mhm.
right? I don't know why I put 0.4. So now you would take, like Linnell said, they have so many ounces of juice. Is there a way to go from ounces to liters?
Yes, I just had it.
Yes.
How would you do that?
I'm looking for the conversion.
Figure out how many ounces go into the liter. I need to go into an ounce. Let me find this.
Put the gallons to ounces.
how many liters go into an ounce?
So they don't have any, do they? They don't have a way to go from ounces to liters here, do they?
No.
No. What do they have about ounces? It's the only thing they have about ounces, right? That's the only thing they give me about ounces. Now watch, the whole thing about math is what's happening right now. You have to first figure out what approach are you going to take, right? So I can go from ounces to cups. Can I eventually follow a path that will get me to liters? Well, what's the direct going to liter? What directly goes to liters? Quarts.
Quart.
The one we just, right? Can I get from cups? I can get from ounces to cups. Can I get from cups to quarts?
Yes, but you're gonna take
So I
some
can go
steps.
from ounces to cups to pints to quarts. Now here's where I want to point out something to make this a little bit quicker. Now stay with me now. You could do all this work. So in this case, it would be, see how we had 1, 2, 3 pieces to this? Because there was 1, 2, 3 steps. So how many pieces are we going to have for this one?
1, 2, 3, 4.
4. But, so you could do that. That would be beautiful. You could do that. You could set it up. So it looked like this, right? You have blah, 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 blah. But one little thing I want to suggest is, you ready? If 2 cups is 1 pint and 2 pints is 1 quart, how many cups to make a quart? So 2 cups to make 1 pint, 2 pints to make 1 quart. Can you just see how many cups it takes to make a quart?
2 cups to make 1 pint.
And then 2 pints to make 1 quart.
4 cups.
4 cups
Yes.
makes 1.
Because every pint is 2 cups. And if it takes 2 pints to make a quart, it takes 4 pints to make a quart. I'm sorry, 4, get out of it. 4 cups
4 cups to make a pint.
to make a quart.
I mean the quart, yeah.
So I could actually so what I just did, you don't have to, but what I just did is I created a new conversion that's not on the chart, but using something they gave me on the chart. That's fine. So now I don't have to take all this many steps. I can go ounces to cups to quarts. I can go directly from cups to quarts if I want to, using that I just created. This isn't just a part of this class. This is getting through life. We have to know how to convert shit. We have to. And some of you guys do this sometimes, depending on what you've had to do in jobs and so forth. And so you have a little bit more practice with this. And some of you guys maybe haven't had to do this much. But it's a very good skill to have. And you can create your own conversions based on other stuff that you know. So a real quick, simple example of that is how many feet in a yard? You guys know 1 yard is how many feet?
3.
3 feet. And of course, 1 foot is 12 inches. So how many inches are there in a yard?
36.
36. Every foot is 12 inches and every yard is 3 of those. So 3 times 12, it takes 36 inches to make a yard. That does not sit on this chart anywhere. I don't think. I didn't look. I would be very surprised if they had 1 yard. No, but I can use that now. I can use that now anywhere because that's the true thing. It's a true conversion. Do you guys get that idea by itself? Do you ever have to do that? No, you don't have to. All right, so we did the milk for that problem. You just have to do the juice for that problem. And then you can finish that problem up. Okay.
I have a question.
Yes.
So it's showing, go back a second to the 0.47 liters. So
Yes.
Once we do all 3 and we change it from liters to milliliters, I'm seeing here in the metric system that it's 3 over to the right. Is that correct?
So if you have, so let me just show you how to do this. So if I have, let me make this again. So if you have liters and you want to go to milliliters, it's 1, 2, 3. Yes.
Okay. So my question
Three-
is
Yeah.
if you have 0.47 and you rounded it to that, and then you take all three of the numbers and then you add those to get milliliters, wouldn't the rounding be a little off if you only use the 0.47? Couldn't it possibly be a different answer than what the book says? Because,
Yes.
okay. So how would you do that to make the the rounding correct when you're doing adding all three together? Would you do more?
So, since we're doing a lot of these, not really by hand, but we're doing step by step, I'm not going to be as stringent on the absolute rounding. If the exact answer was the most important thing, then I would do all this stuff in directly in the calculator and not round anything. Right?
Okay. But isn't
But I
that
wanna
what
give
it
you guys-
is? I'm confused. That's why
Go
I'm
ahead, sorry. Say-
Isn't that what it is? We're trying to get the correct answer, and we would have to add all three of those, right? So that's why I'm kind of confused.
What's more important in certain math problems, the key is to get the exact answer. Certain math problems, that is not the point of it. The point of these math problems is to get used to how to convert,
Got it.
right?
Okay.
So if I can be lenient on the rounding issue so that it's easier for you to latch on to the conversion issue, that's beautiful. That's what I'm trying to teach you in this section.
Got it. Okay.
So, yeah. But I mean, generally, it's a good question.
Makes sense.
You really, in just a normal problem out there in the world, you don't want to really round until the end, right? But
Okay.
I don't want us carrying too many decimals, and that's kind of getting in the way, and I don't really understand it as much as if I just let you be a little more lenient with the rounding. Yeah.
All right.
I want you to get the idea of converting. Yeah. Oh, crap. We are like way over time, aren't we? Yeah. All right. So let me clear all that. I'm going to clear all that. I guess it doesn't matter. So what you guys got to do, if you haven't finished section, what is this again? What section are we in? This is 2.4.
2-4.
Thank you. If you haven't started 2.4, I need you to start it. And then I need you to come back tomorrow with some specific questions. And then we'll go from there. I am going to be a little lenient. Don't round too much, right? Maybe a couple places. Just so you could focus on the idea of conversions. That's what I want to focus on in this section. Okay, so you got to get in there and try some out. All right. So that's enough for class today. I'm going to officially say class is over. If you want to hang out and ask some more questions, feel free.
I do have some questions for you, unless there's somebody else that wants.
I mean, go ahead. What's up?
What are good? I guess reading comprehension is the same thing as reading. So I was kind of I'm noticing some troubles that I'd like to ask you on what's good when reading a math problem. Like, I guess, like, is there any books that you might suggest in reading to help be able to understand or read math problems a little easier than having to go 2 times or 3 times through the question?
Well, no. You're going to have to do that. In fact, that is very often, that is a valid step in reading comprehension, any reading, not just math. You will sometimes have to read something through several times. What we see in mathematics is you read through it once to get a certain idea of something, and then you read through it again to get other ideas. So when we get to word problems, I teach that you never just read through it once. You read through it at least twice. And the first pass is to gather something. It's not even mathematical. It's just to gather what's the problem dealing with. And then the next time you read through it, you look for the math, the numbers and stuff like that. But in our next section coming up, they actually have all right, where are you next section? Here we go. This is not exactly what you're talking about, but it's sort of related. It's kind of like 4 steps for solving problems. They don't really get into the way I do it. They don't really say to read it through twice, but this is more about word problems, which is really where reading comprehension becomes very important. With the problems we've been doing so far, you just have to slow down and make sure you know what they're asking you. Make sure you know what the actual question is before you start trying to do stuff, right?
I agree. So that's why I kind of, just I'm asking these questions just so I can. I mean, I haven't seen school in a while, but seeing school, like I feel it's a skill that has to get built up with time. But I'm saying like in learning, like being able to, just because it's all new, like it's all new information again. But I guess I just thought it might have been odd that I have to read the question more than 2 times, maybe 3 times. That's it.
Oh, no. So get off your back about that. Of course you're going to. I would find it weird if I didn't.
All right.
Yeah, because very often you read through it kind of quickly at first just to get the general idea.
Yeah.
And then you go through it again a little slower. So then, because the general idea tells you what you need to get from it. But you can't get the general idea until you read the whole thing through kind of quickly. So you're going to have to read through these a couple times. So don't think that that means you're doing something wrong. That means you're doing something right.
All right, cool.
Yeah.
So yeah, that's it. I guess we'll see you tomorrow.
Okay.
All right. Thank
All
you
right.
for your time.
Sure. Ruben, Ian, you guys out there? I'm going to head out. All right. Oh, there he is. All right. See you guys.